So in this problem, we have a wagon being pulled horizontally by exerting a force of 20 pounds at an angle of 30 degrees with the horizontal. So the idea is we have a force, F, that's acting in this direction, and it's acting at an angle of 30 degrees with the horizontal. We know that the magnitude of that force is going to be 20 pounds. Now we want to know how much work is done in moving the wagon a distance of 100 feet. And so we assume that we're moving that wagon 100 feet horizontally. So that we've got our vector D that's going to be 100 feet horizontally. Now the question is, how do we get our vector F that has a magnitude of 20 but acts at an angle of 30 degrees with the horizontal? Well, the idea is that we just take the magnitude that we want, and then our first component is the cosine of our angle, and our second component is the sine of our angle. So this gives us 20 times our root 3 over 2 and 1/2. So that once we distribute our scalar across to both terms, we have a vector that's going to be 10 times the square root of 3 and half of 20, just giving us 10 for our vertical component. Now if we want the work, well, that will just be our vector dotted with the distance over which it moves. So we have the vector 10 root 3, 10, dotted with our vector 100, 0, which gives us, multiplying like components, 10 times the square root of 3 times 100 plus 10 times 0. And we add those together, and so we get 1,000 times the square root of 3, or approximately, and the units on that one, because our units on our force were pounds, and the units on our distance were feet, then our units of work will be pound feet. And so we've gotten our answer. How much work have we done? 1,732.05 pound-feet of work.